Ladies and gentlemen, please welcome from Accenture, Global Managing Director of Emerging Technology Innovation, Adam Burden.
Thank you very much. Thank you, everyone. You know, I'm actually going to start today with thanking our partner, Red Hat. You know, I've had the good pleasure of working with Red Hat for a number of years, and I think I look at them as you know, somewhat as an inspiration in the industry. What their conviction and what they have believed in open source, I think has helped us really get to a level of innovation in our markets that we wouldn't otherwise have achieved. So I'd like to give them a little round of applause. I think they've earned it. So thank you, Red Hat. Now, and you heard that when Jim Whitehurst was opening the summit this year, a little bit about innovation and how open source has really helped to spark some new things. And you know, that's a really part of the subject of what I wanted to share with you today. So I have a bit of an unusual title about the Portsmouth block mills. So probably a few of you in here wondering what exactly it is that this might have to do with open source or with Red Hat. And it's really about taking inspiration from history, in this case from the British problem that the British Royal Navy had in the 1800s and 1700s, and how do we apply that to help us fix problems today? So that's a little bit of the story I'm actually going to share with you. So maybe a show of hands, was anybody here last year and heard me talk about this knot up here? Anybody? So a handful of folks saw that discussion. So I learned a few things last year when I came to Summit. The first thing that I learned was that you don't wear ties at the Red Hat Summit. So notice that I took that lesson to heart this year. So no tie. The second thing I learned is that my mother actually Googles me occasionally and found me on YouTube, and then she sent me a note afterwards and said, I'm more confused than ever about what it is you actually do for a living. So I learned that as well. But the third thing that I learned is that at the Red Hat Summit, that we who attend these things, we're not attendees, we're participants. Because after I shared some of that and gave folks a little bit of a lesson about how do you apply bold thinking to solve a problem, I got a lot of feedback about that's great. I appreciated some input about how to get started on that, but we're lacking some of the tools to actually fix the problems of legacy that you talked about. So the point of what I was making was basically that this Gordian knot was an allegorical reference to what we have today with legacy applications and particularly custom ones, and how difficult it was to consolidate, rationalize, perhaps even modernize them, and it took a lot of effort or even bold thinking or bold change. So in this case, Alexander the Great didn't really try to untie the knot, he just simply took out his sword and cut it in half. And the point I'd like to make this year is that sometimes you actually need a scalpel instead of a sword. So what we're going to do, we're going to talk about the thing there on the right, which is a block, or it's actually a pulley. It's a pretty important device. It's been around for, I think, better part, maybe 1,000 years or even longer. I think the Egyptians actually may have used it to help build pyramids at one point. The pulley basically is a device that gives you mechanical advantage. So you need it if you're lifting something really heavy. You need it for moving objects, and it's particularly useful on sailing ships. So from a problem that existed for many years is how do we lift these really heavy sails without having a massive number of sailors on board to be able to do that, and that's one of the things that this actually helps solve. So let me pause there and actually tell you a little bit first about who Accenture is, because I realize always when I talk to some of the crowds, it's a little unfair. I have to share a little bit about a background about who Accenture is. And it's remarkable because we've become such a big organization from where we are when I started 21 years ago at this point. With 259,000 people working in 120 countries, we actually have 44,000 Java developers. Today we're serving 89 of the Fortune Global 100 and more than 3/4 of the Fortune Global 500. And it's all around a simple mission of helping our clients become high-performance businesses. And that can be, take many forms in terms of management consulting, technology services, or even outsourcing. Now, if you have followed the news in the last several weeks on Accenture, and maybe some of you actually had seen that, we announced a $400 million cloud technology investment. And one of the things I'm going to share with you today is a byproduct of that investment. So one of the things that we're actually developing as part of that investment activity to help accelerate the migration to cloud. This is almost, if you will, our doubling down of putting investment, capability development, assets, and tools to help our clients accelerate their journey to cloud. And we feel strongly about this for a couple of reasons, because the barriers to entry for competition have never been higher, or I'm sorry, never been lower at this point, and the pace of that competition is actually accelerating. So in order for us to serve our clients properly, we really have to give them capability and abilities to move to cloud quickly. So let's talk for a few minutes, too, about Accenture and Red Hat. We actually have more than 11 years in our partnership at this point. We're proud to work with them. We actually do some really innovative things together in the marketplace, collaborating on enterprise-scale projects that are out there. We work together on a lot of custom development, integration, migration, and cloud projects. I think when you came in, probably on your seat, there was an overview of something called the Accenture Public Service Platform. And that's one of the many innovative projects that we've collaborated with Red Hat on to solve industry problems. Our activities also include, how do we bring forward our own workforce, so our 44,000 developers, and get them comfortable in developing in cloud. And one of the things that we've done in the past, it's actually 2 years running now, is we've run a competition called the J Prize. So J Prize is open to all of our 44,000 developers, and we ask them to build applications on public OpenShift and submit them for competition. And we just recently wrapped up the second run of that competition, saw some really amazing things and some really creative and innovative things that were developed by our folks. So we have a history of doing pioneering things. We're working on OpenShift Enterprise now. I think we've got 5 different projects that are running in that area, and we're really proud of our relationship with Red Hat. Let me just share something about me. Now, first of all, I spent my career, a lot of my career actually, working in what's called legacy modernization for Accenture. And I apply this learning, I guess, to a lot of what I do. And it's really hard work sometimes. First of all, you have to really admire some of the folks that were writing code back in the 60s and 70s, dealing with really limited operating systems and memory spaces and stuff. They did some really creative things. But it's also really hard to understand and unravel today. So a lot of what I take and what I've learned over the years is how do we make that legacy or those legacy challenges, how do we deal with those in a more efficient way? Because if you just look at it in the traditional approaches, it's really backbreaking labor. So we need pulleys. My job today is actually running global emerging technology innovation for Accenture, and I'm proud to say it's actually probably the coolest job in our entire company. I get to do things, I have groups that specialize in things like video analytics, machine learning, artificial intelligence, drone technology. We're starting to do some things with autonomous vehicles, and indeed cloud platform as a service as well. So it's our job to sit at the intersection of technology innovation and pioneering clients so that we're ready as a company when our clients want to do something with a new or emerging technology that we have the skills and capability to do it. And that's honestly one of the reasons why we partner with Red Hat so that we can get access to those things early, begin to develop those capabilities and skills so we can bring those to our clients and work with them. Now, I would say my convictions today are probably, there's 2 things I feel very strongly about, is adoption of cloud and how do we accelerate it. And the second one is I also work on things with next generation human-computer interface. So for a few folks that were with me at dinner last night, you got to see some photographs of me wearing this rather odd contraption on my head. I wanted to actually use that today, but my wife told me that if I wore it in public again, that we wouldn't be together much longer. So you're not going to see me wear that today, unfortunately. But some of the things that I work on and everybody in our group is responsible for is sort of keeping tabs on the pulse of technology. And this particular one is really intriguing about using brainwave patterns to actually control devices. So I did a presentation the day before yesterday where I completely controlled it just by thinking about moving the slides forward. So there's really interesting innovation that's happening in this space, and we'll be taking some of those innovations and applying it for value to our clients. And I'm also one of 82 master technology architects inside of Accenture. So let's go back to our story. So who invented mass production? Now, if you ask most folks this question, they'll say, well, Henry Ford, right? That was the Model T, 1910 or so. And the answer is that's, he may have industrialized it and publicized it really well, but it actually wasn't him. And now, there's actually a lot of debate about, what exactly is mass production. And in fact, if you look back, I don't know, to several thousand years ago, there's some suspicion that Genghis Khan was using this somehow to build weapons and some other things. But when you look at the application of machinery to production of devices, that was actually done by a guy named Mark Brunel, and it was done in about 1803 or so. And it was to solve a problem for the British Royal Navy. So I'm a big fan of necessity as a mother of invention. I think that's an important thing for us all to keep in mind, but it also should inspire us to do things faster and quicker sometimes. The British Royal Navy at the time was huge. They had a lot of colonies to protect, and they had a lot of territory to cover. So they had warships, 70 guns on them, thousands of square feet of sail, and they literally used 1,000 of these blocks on board, sometimes more, to actually lift sails, move cannons, whatever it is that they use them for. So these are really important devices to them. And one of the problems that they had was they needed 100,000 of these every year. Can you imagine? Each one was handmade, bespoke, custom-made by a craftsman. So they had all kinds of challenges with how long it took. It was very expensive and very inconsistent in terms of quality. Sounds like custom application development. So around about 1795 or so, a guy named Samuel Bentham, Sir Samuel Bentham, was actually appointed to go and run the Plymouth dockyards at the time, and he was appointed to modernize it, whatever that meant, in 1795. And it included adding steam machinery. But the steam machinery was intended to, pull ships across the yard and heavy logs and things like that. But this problem of the blocks was really getting challenging with the British Royal Navy. In about 1802 or so, it was just chronic. And there was an edict that was put out. So the British Royal Navy wanted to add steam power to make block production faster and cheaper. It was pretty simple. And basically, Samuel Bentham engaged this guy, Mark Brunel, and said, hey, we need to figure out a way to use machines to make these faster and cheaper. Can you help us do that? And Mark Brunel said, absolutely, I'd love to do that. And they came up with this idea, and it'll sound very familiar to all of us. And basically what they said was, we're going to use a series of normal machines and some specialized machines. We're going to have a line. We're going to pass stuff down the line. At each station, things are going to be added to the blocks, and at the end, you're going to have finished blocks. And by 1807 or so, after they'd assembled these 45 machines or so, by 1807, they actually were producing 130,000 blocks a year, well in excess of the need of the British Royal Navy. So I assume they were probably selling them on the open market as well at that point. And it was transformational for them. They had higher quality. I guess the British at that point won more naval battles or something, were able to take more territory. But it was really an important invention. And there are a couple of really surprising things about it that I've learned. One of them was it actually became a tourist attraction, if you can imagine that. Like, people actually went in 1807 to go visit the Plymouth block mills to see these amazing machines produce these blocks, because I guess it was so different. The other surprising thing that I learned was what they did here wasn't really widely adopted in industrial manufacturing for about another 40 years or so. So until about 1850 or so, in British manufacturing, you didn't really see it show up. So how does this apply to today? Well, first of all, I don't think we can wait 40 years to try and fix the problems of legacy. We've already been dealing with it for 40 years or longer, as well as move things into our cloud. So we've invested a tremendous amount of energy in building legacy applications over the years. Our steam engines are creating this enormous cloud that's there now. How do we begin to take advantage of that? And we have the challenge of these legacy applications written in numerous different languages, COBOL, Power Builder, Visual Basic, and others, many of them actually being deprecated, or they don't necessarily provide the services or functions that Accenture's clients, and probably many of you in the room, want or need. As new channels become important, mobility and otherwise, modern programming languages, Java, .NET, and others, become that much more important. So this is the problem that we set out to solve originally, about how to move these things in a faster way to some of these more modern programming language. But the way we solved it, the way that we're evolving it, is actually to be able to move them directly onto platform as a service architectures, and of course, that includes OpenShift. So here we are. We have, our collection of legacy systems. Imagine this guy bent over with them carrying them on the back, kind of dealing with them in traditional ways, and he really does. He wants to get to cloud. So now I'm going to show you a short video. We'll actually do a little demonstration of some tooling that we've developed with our ecosystem of partners to actually tackle this challenge. And I apologize, you're going to be humming this later. Okay, so there is an answer. We have something called Legacy to Cloud, and it's a language migration service from Accenture that allows us to take legacy languages and move them to modern ones, and directly onto PaaSes. So those are the, some of the ones that we support, any legacy app on any platform. And we also moved to any PaaS, although OpenShift is certainly one of the ones that we'd like to highlight here. And similar to the lessons that we took from the assembly line, we have a process. We use parsing first to extract this, and reverse engineer the application. This will look really familiar to some of you that have done any kind of programming on mainframe at some point. A nice 3270 terminal, where you get to see what this application looks like in its native form. Or let's go take a look at the source code, and we're actually going to mark it up and do some annotation on it. We're going to fix some things inside of the source code that aren't quite correct. We'll do that in a largely automated way. And then when we're done with that, we're going to transform it from what's called a platform-specific model into something that look really familiar, UML. So you'll see a class diagram show up here in just a second. And then there's an activity diagram. And we will actually review this. We'll make some adjustments to this because it's not a perfect process, but it works very well. And oh, by the way, most clients that we're doing this type of thing for, they ask us to do more because moving to cloud is not just about getting there and being cheaper, it's new services. And once I'm done with that, I'm going to forward engineer a new application on OpenShift. So here you see me basically committing a Maven project, deploying it, and having it up and running and testing. And I'm going to go take a look at that. I want to make sure my REST service actually functions correctly. And it does. And that's it in 2 minutes. Now, there's a few things that are important to keep in mind with what we have in this tooling. The first thing that's important is there's some assembly required. So just like blocks, we can produce these things in an assembly line type fashion. But at the end, somebody has to actually put the rope through it, screw some things on, test that it works correctly, that type of thing. So this is not a push button type process. But it gives you a huge mechanical advantage, similar to the pulleys. It gives you a huge mechanical advantage to do things faster, cheaper, and helping to deal with some of the legacy debt problems. So when I got the questions last year about, I liked what you had to say about thinking differently about the problems of legacy, but there's a few ways to actually solve the problems of legacy languages and move them into modern programming language. We weren't getting those requests from our business counterparts. And my reaction to that was, well, I kind of hinted at this in our session last year. I said that we're working on some tooling like this. My action was, give us some time. We're going to produce something with our ecosystem of partners that's going to allow us to do this at scale. And I'm proud to be able to share some of that with you today. We're already doing this for some clients. We've used this tooling actually to move to more traditional .NET and Java Spring platforms already. In fact, even running Red Hat Linux and JBoss. And now we're doing it for clients that want to move into platform as a service architectures too. And the beauty here is we can do this at scale. We can do it better and faster and cheaper. We're not doing it bespoke. Each one is done exactly the same way. We're service enabling the applications along the way so that when we get there, our applications are interoperable with each other. They've all been REST enabled or API enabled so they can communicate externally. So the new features that our business customers want are all there. They're more maintainable. We actually do some things along the way to help with that, not the least of which is creating UML modeling to be able to reverse engineer the applications again in the future if you needed. And we're testing, assembling it, and deploying it. Now, if there's one thing I've learned in talking with clients about this, is that there's a lot of skeptics out there. Everybody in this room has probably run into some snake oil over the years and seen some things, some technology things that were probably too good to be true. Well, I'm a transparent guy, and there's a few things that I'll tell you about this during the course of our discussion today about how does it actually work. Well, first of all, you heard from Jim Whitehurst and also from Paul Cormier about the importance of ecosystem of partners. We can't, no one company, I believe, can solve the problems of today. And we have to work together in a collaborative fashion. And that's indeed one of the things that we did here to make something like this work with our partner Blue Age, with Red Hat, OpenShift, and then obviously Accenture. Now, on the other side of the screen there, I show a picture of a sausage grinder. So everybody's kind of heard the analogy of where's the sausage factory in this? And there is some hard work that has to be done. When you are looking at some of the legacy source code and transmodeling it, you do have to annotate it. It does take some work. So this thing is not just pushing a button and watching something coming out on the other end. But when we've done this, we can do it for most of the time, half or even less of the cost of rewriting the application. And we do it in a fraction of the time as well because of the automation. So very similar to some of the benefits of the assembly line production that Mark Purnell did, we do this basically in a factory-type fashion with specialized people and tools at each station that allow us to do this quickly, fastly, and cheaply, as well as with a great deal of quality for our customers. So I imagine there's still some skeptics out there, which is fine, because if you want to find out some more, we're happy to share that with you. Later today, I believe, 4:50 to 5:50, in room 210, we're going to show this. We'll walk through it in detail. And just like last year, I encourage the folks in this room to not be attendees, but participants. Come and ask us the hard questions. Make sure that we're helping solve this problem, because I don't pretend that Accenture has all the answers to our industry's challenges and adoption of hybrid cloud. And I want to make sure that we understand where some of these difficulties might lay so that we can continue to improve and adapt this into the enterprise. So I think looking ahead here is really important. And one of the things that you heard me talk about earlier is my conviction about dealing with the problems of legacy technology and how I spent many years working in that space. I think that as we examine what's happening at our clients, that competition bar which continues to go down because the barrier to entry for new competition to come in and begin to take advantage of the cloud is really creating a disruptive force in our enterprise. We owe it to our clients, and many of you are actually sitting in the room today, to think about how it is that we're going to address these problems. And we owe it to you to come to the table with solutions on how to address them in a way that's cost effective and allows you to take advantage of cloud enterprise, whether it's public, private, or hybrid in a coexisting world, and how do we actually accelerate it. So at the end of the day here, what we're really trying to do is just take a page from the history books and getting started with adopting the hybrid cloud. So that's a little bit about what we're trying to do in Accenture in our emerging technology group. And I hope you enjoyed seeing that insight, and will come visit us later today and hear a little bit more about how this actually works in detail. Thank you very much.